Hey folks, now that you've researched and drawn some basic topologies, let's look at each of these and learn about some of their features and why you would choose to build a network with one map over another. So let's start with bus. Bus actually is pretty outdated. We don't really use it much anymore, but it's still important to know because a hub is technically a bus network. Even though it looks like a star if you were to, put that hub in the middle of your network and connect everything to it, it physically makes something that looks like a star, but in fact, logically and electronically makes a bus. So a bus is a common line, a common cable, essentially, that all of your computers attach to. Now, a traditional bus like this would actually have something on the end of it it wouldn't be a server, but it would be some sort of icon that would be a terminator. So we'd put a terminator here at this end, oops, and another one at this end, and they would stop the traffic. Now, the problem with a bus is that electrically only one device can talk. So imagine this device in the middle wants to send data. So it sends it down this line onto the common line, and those electrons are going to go both directions, and then they're going to go up to this computer and to this computer. So both of these computers receive whatever this one sends, even if it's not meant for them. So first of all, it's a security problem. But also, if this computer is putting electrons on this copper wire, this computer cannot do it at the same time. If they do, those electrons get all mixed up and your message is lost. So you have collisions. So buses are actually pretty terrible by today's standards. Again, we're going to learn about them a little more because we want to compare a switch to a hub and see why a switch is so much better. So let's move on to ring. Here's an example of a sonnet loop as a ring network. Now, a sonnet loop is a pretty good type of ring. The beauty of a sonnet loop is that traffic can travel both directions. Some rings, like old token ring networks, are terrible implementations of ring. In fact, they make ring bad because data only travels one direction, and if the line gets broken, the entire network fails at that point. Now, here's a network based on one that I used to work on, and we had POPs, or points of presence, in Bloomington, Martinsville, and Indianapolis. And so Bloomington was connected to Indianapolis via this fiber optic cable, and our sister company ran this. We actually maintained this cable ourselves. Now, when you get up to Indianapolis, that same router has a link back to Martinsville, which has a link back to Bloomington. So you can see that data can travel either direction. If we need to get from Bloomington to Indianapolis, we can send it this way, or we can send it this way through Martinsville. Now, that's probably not as good most of the time. So here are your options. You could split traffic. Half goes this way, half goes that way. And that's going to load balance. That's good. But what if a backhoe decides that they don't call before they dig and they break that connection? Well, all the traffic that was going that way now goes this way. So this line gets a little more saturated, but we're still up and running. So this is good. This gives us a lot of reliability in this loop. So ring networks, depending on how they're implemented, can be very good or very bad. Let's pop over here to a star network. So a star network is probably the one that we're most familiar with. This is the way that wired Ethernet works most of the time. So the lab in our classroom, there's a switch in a rack at the back of the room. There are 20 or so computers in the lab and then another couple around the room, and they all connect back to that switch. So the switch is the center of our star. Now, the beauty of this design is what happens if somebody trips and breaks this cable right here? Well, that's okay. That computer's down, but it does not affect any of the other computers. What happens if the switch breaks? Well, okay, now everybody's down. So we do have a single point of failure, but we have it on a pretty robust piece of equipment. So we don't see switches fail all that often. Now, of course, when we draw this star, we often put our computers out in more of a star fashion like this, but it really doesn't matter. The key is logically how it works, not physically how it works. So a star is probably the most important one to know because it's the most common type you're going to run into on wired and even wireless Wi-Fi based networks. And lastly, we have mesh. Now, I had you guys break apart partially connected mesh and fully connected mesh. The only real difference is that in a fully connected mesh, every device has a direct connection to every other device. So what you see here is a fully connected mesh. In a partially connected, some devices have multiple connections to other devices, but not all. Let's grab another laptop here. And if we connect this laptop to here and this laptop also, to here, we now have a partially connected mesh. This laptop connects here and here directly, but it does not connect here or here directly. Now it does have a path, right? This laptop can contact both of these by going through an intermediary. So we could go here to get to here, or we could go here to get to here. So in either case, we have a mesh, just one is fully connected, one is partially connected. But notice the scalability problem. If we take this computer away, here we have 4 computers. How many cables are we looking at? In a fully connected mesh with 4 computers, we have 1, 2, 3, 4, 5, 6. That's a lot of cables to connect 4 computers. What if we add another one? If we add this laptop, we are at 6 cables. Now we're going to add 7, 8, 9, 10 to connect to everything else. Let's do it again. 11, 12, 13, 14, 15. 15 cables to connect 6 computers. All of a sudden, this doesn't seem very reasonable, does it? So mesh networks aren't usually used in wired environments. This works much better in small wireless environments. There are some wireless sound packages out there by Sonos that do mesh networking. And the beauty of mesh is that it can keep everything really tightly in sync. So if this laptop and this laptop and this laptop are all trying to play music at exactly the same time from different rooms, they need to coordinate. If this one starts even 50 milliseconds after this one, it's going to sound like an echo. So these need to constantly keep in contact in order to stay synchronized. So that's what mesh is good for, usually synchronization in a wireless environment. So there you have your basic networks. Bus, which is not used much today and in fact has some real problems in terms of reliability and security. You've got loops, which depending on their implementation can be reliable or in fact can be unreliable. You have star, which is the most common one that you're going to see overall and definitely the most common in a wired Ethernet environment. And mesh, which is mostly used in wireless environments in order to keep synchronization.